Welcome and thank you for joining me. Now we're going to take a look at question number 13 from lesson U1A5, and this is the practice sheet. So we're trying to prove that given two vectors A and B, the following expression is true. So we have A minus B crossing A plus B equal to 2A cross B. So let's take a look at how we can simplify the left side first. So the left side is A minus B crossing A plus B. So the way that we multiply this is we're going to take the vector A, multiply or cross A minus B. So we'll write in here A minus B, so vector A minus B, cross vector A. And then we're going to have the next vector in the expression, vector B, crossing A minus B. So A minus B crossing vector B. And this is possible thanks to the distributive property of the cross products. I'm going to write that down here. Now next, I'm going to check and see how we can expand and simplify here. Now again, we have the cross product of two vectors and we can apply the distributive property once more. So in this case, we'll have vector A crossing both A and B. So we have vector A cross A, and then minus B cross A. In a similar way, we're going to cross vector B with A minus B, or vice versa. So we have A minus B cross B, which will be A cross B. And then, as you can see here, you have a minus, so that must be minus B cross B. Now, a vector cross with itself will always equal 0. And we know this because that would equal magnitude of A, and then the sine of the angle made between a vector and itself, which will be sine of 0. And because sine of 0 is equal to 0, that will make the whole expression here equal to 0. So we're going to say the same thing for the last term in here, B cross B, which will be the magnitude of B, and then the sine of angle 0, because any vector makes an angle 0 with itself. So here we go, we have another term which equals 0. So we're going to say that we're left with the following. So we have negative B cross A plus A cross B. So negative B cross A would can also be written as, or we can transform this expression. So we're going to start off with A cross B, and then plus negative B cross A. And because I want to actually combine the vector A, so I'm going to rewrite this as A cross B, nothing changes to this, and then subtract negative A cross B. Okay, so basically what we did in here was we wrote vector A as minus the negative value of A, and then we kept the minus out for the vector B, which is inside it. So remove the brackets and we get A cross B. Now remember that it is very important that we keep the vectors in order in cross product, because we cannot switch the vectors around when we cross product the vectors. So sorry, here we go. So A cross B, and then will be plus A cross B. Okay, so the two minuses in here will make A plus. Now, as you can see in here, we have the cross product of the same pair of vectors. So we have two of them. So 2A cross B. Right? So we have, let me highlight this. So 2A cross B. And that's what we have here on the right side. And that's the end of the proof here. Thanks for watching again. and stay tuned for the next solutions.